everyone. Today we are going to learn about real numbers. This series is for teaching you about the basic maths. Especially, I'm making this series for those children who are especially BPC, who has the very less knowledge about math and has fear about math. I'm here to teach you these series of classes which can help you remove your fear and also make maths easy, because I'm also a BPC student and I know that many people are afraid of math. So with this, I'm starting with the basic math, because in the EdSet they have made it compulsory that we have to attempt all the subjects, and math is something that is bothering even the social students, as well as social methodology students, as well as the biology methodology students. But don't worry, I have a series of lectures which help you in learning math in an easier way. I have some tricks also available. So let us start with the first one today. So first one today we are learning is about real numbers, which is the first chapter in the math syllabus that is given in the TSEdCET. Okay, so real numbers. So real numbers are the numbers that can be quantified on a number line. Okay, and there are two types in that. In the first one is the rational, second one is the irrational ones. So in the rational we have integers. So they will be from minus. The line starts from -3, -2, 0, 1, 2, 3. Okay. Next we have whole numbers. Whole numbers starts with 0, 0, 1, 2, 3. So next we have natural numbers. Natural numbers, they start from 1, 2, 3. Okay. Then what are irrational numbers? Okay, what are irrational numbers? Irrational numbers means they can't be expressed as a fraction of any integer, any number. So those which are repeatedly happening, like root 2 for example, it is 1.414, it keeps on repeating, right? Those kind of numbers which are continuously repeating, they will be in the decimal form only, they will not be in the fractional form also, always in the decimal form. These roots which are recurring are called as irrational numbers. So if you're someone as smart as me, you might be getting a doubt, ma'am, there are real numbers. You are saying that. Are there any unreal numbers? Any of you know that? Okay, there are unreal numbers. What are those unreal numbers? Real numbers are something that can be written on a number line. So for example, this is a number line, as you can see. So minus 8, anything from infinity to minus. So integers, let us consider as integers. So minus 8, so and so, 0, so and so to minus 8 for example. Okay, in that case, these all can be quantified on a number line. But there are some imaginary numbers. What are those imaginary numbers? The imaginary numbers which when squared, they will give, so for example, I is an imaginary number. When this I is squared, the answer will be -1, means minus negative number. So the result will be a negative number. When an imaginary number is squared, it will give a result of -1. We don't know the actual value of this imaginary number. Then why are these unreal numbers existing? You might get that doubt also. So these unreal numbers help in understanding the change in the current flow in AC and DC currents, if you are aware. So there will be some kind of sine kind of values that will be formed, 0, -1, -2. So with this they will estimate the power supply that is happening, how is it happening, if there are any fluctuations, how to handle that. In that case, the imaginary numbers are used. These imaginary numbers, they are unreal. What are they? We'll learn about even numbers and odd numbers. So even number is any number. Take any number, if when it is divided by 2, the remainders should be 0. If any number taken, for example, let us take 44. So divided it by 2, 1, 2 2s are 4, then 4, 2 2s are 4, again the answer is 0. So this 42 is a even number. So even number is any number that when divided by 2 leaves the remainder as 0. So even, so 2 divided by 0 itself is also 0 only. Then next we have odd numbers. So odd numbers, when they are divided by 2, they will give a remainder any number. So they will leave a remainder 1, any number. So like for example, let us take 43. So when divided by 2, 2 is a 4, 3, 2 1 is a 2, the remainder is 1. So 43 is a odd number. Okay. So try with more examples. Let me give you some questions. You find out and tell me the answer in the comment section. Which of these are even and which of these are odd? Okay, these are the examples. You can find out which is even, which is odd. How much ever the longer the number is, how many digits whatsoever it is, you can simply check the last digit. So just check the last digit, divide that last digit by 2, and if you get the answer as 0, then it is an even number. If you get the answer as not 0, 1, 2, anything, then it is, usually the answer will be 1. Okay, so then it is an odd number. Okay, even those, for example, see, you can take it as 197. Okay, just you have to check this last digit. So divide that last digit by 3. 2 1s are 2, so 2 1. So this is an odd number. You need not search for everything. The last digit is just enough. Okay. Now let us see what are prime numbers and composite numbers. Okay. What is a prime number? Prime number is any number that is divisible only by 1 and itself. Itself means the same number. For example, 2 is a prime number. So 2 is divisible only by 1 and 2. For example, I will tell you one more example. It will be more clear. A simpler example like 5. So 5 can be divided. So when divided, the remainder should be 0. So when 5 is divided, so it can be divided only 1 into 5 is possible, is equals to 5, is equals to 5, and 5 into 1 is equals to 5. There is nothing in between. So for example, if you take other number, right? So for example, now 6. So 6 is divisible by 1 and 6. Okay. But also 6 is divisible by 2 and 3. So when it is for prime number, we need only 1 and the number itself. But there are 2 more numbers that are coming. So 6 is not a prime number. Then what is it? Not prime means it is composite number. What is 6? This is a composite number. Composite number will have more than the number 1 and itself. There will be some more numbers in which this number is divisible. The given number is divisible with 1 and 6. Other than the 1 and itself, some more numbers will be available. Okay, let us try some more examples to be more clear. So for example, 27. Let us try this. So 27. So 1 into 27 is 27. So will it go in 2 table? Is it divisible in 2 table? It is not. So because the last number is not divisible by 2, that's why this is not divisible by 2. So this is the rule for divisibility rule. The next one we have is 3. So 27, is it divisible by 3? Yes, it is. So the rule for 3, if a number is divisible by 3, when you add up both those numbers, for example like 2 plus 7 is equals to 9. The number 9 itself is divisible by 3. So then it is divisible by 3. So 3 into 9 is 27. Is there any table? 4? No, it is not divisible by 4, because in 4 table 27 will not come. Okay. Then 5. In 5 table will 27 come? No, in 5 table 27 will not come. That is the reason it is not divisible. Then let us check 6. In 6 table will 27 come? No, it won't. In 7 table will the 27 come? No, it won't. In 8 table will the 27 come? No. Now 9 table, yes, 9 threes are. It is 27. So again after that 27 into 1 is 27. So the number 27 has more than 1 and itself. There are 2 more other things. So this number is a composite number. Okay, if you want, I will teach a brief next video. I will teach in briefly about the rules of the divisibility, so that you will understand prime and composite numbers more in detail. Just with small numbers, just take it as homework. Try whether these numbers are prime or composite, and please let me know in the comment section. If you like the video, please like, share and subscribe. And for more, now next video I will be doing on the divisibility rules. I will tell you in detail. If you have any doubts, you can post them in the comment section and I will answer your doubts. And if you want me to teach in Telugu also, I am ready to teach. Please let me know in the comment section. Thank you. Thanks for watching.